Hello, everyone. Welcome to today's Civitas Elliptic third webinar. This is the third webinar in a series of Elliptic webinars. We've been doing 2 webinars before, and you can find all webinars, of course, on the Elliptic website afterwards. Today, we would like to welcome you to share our experiences from the Elliptic cities in using electric public transport infrastructure for the charging of other electric vehicles. And just to give you a little bit of background information why we find this to be an important topic, we have seen in the project that the lack of citywide charging infrastructure can pose a barrier for the wider deployment of electromobility. So since it is not always possible or simply too expensive to increase the capacity of the public electricity grid, we have been looking in Elliptic to show how the existing electric public transport infrastructure, that would be trolley buses, metros, and tram substations, could be used as charging infrastructure for other electric vehicles. And in the project, we've been looking at different approaches, taking into account different infrastructure and vehicle types, but also local context conditions such as energy capacities of the grid, the different institutional setups in the cities, as well as different regulatory frameworks. And today in this webinar, we would like to share these experiences with all of you. Okay, here you can see the agenda for today. My name is Henning Günther from Ruprecht Consult. We are together with the City of Bremen, coordinator of the project. And as I said before, we will present now different aspects related to the multi-purpose use of electric public transport infrastructure. And this will include 2 presentations from cities that have been involved in Elliptic. That would be London and Barcelona. And they will be sharing their insights that they gained within the project about technical aspects, but also planning aspects related to this topic. So the next presentation would then be David Talbot from Transport for London, and he will talk about using the London Underground electricity grid for the charging of electric buses and Transport for London service vehicles. In the next presentation then, Oscar Puig from Barcelona de Serveis Municipals will be sharing some ideas about using Barcelona's rail network for the charging of electric vehicles. And then in the last presentation, we will also present some findings looking at electromobility from an energy law perspective, highlighting legal and regulatory challenges that we have encountered within the project. Just also to give you a few faces and just to make this a little bit more human, here you can see who's actually involved in the webinar. It will be 2 moderators. That will be myself and my colleague Elisa, who's sitting with me. We will be moderating the webinar and taking care of the questions that you have. And then the panelists are David Talbot from Transport for London, who will present on TfL's activities within the Elliptic project. Then we have Oscar, who's head of the Research, Development and Innovation Department at BSM. And then we also have Hartwig, who's a lawyer specialized in energy and renewable energies since 2007. And he co-founded the law firm von Bredow, Valentin and Hertz in 2012. And as I said before, Hartwig has been mainly involved in the project looking at legal and regulatory challenges. I would hand over now to my colleague Lisa, who will explain to you a little bit the software and how you can actually raise questions and use the chat box in this program here.
Right, so just some technical information to start out with. You can dial in into this webinar using either your computer or your telephone, but then you also have to dial in the PIN that's shown in your webinar window to be able to actually interact with us. All participants are muted by default. We can unmute you if you want to communicate with us. And if you want to do that, if you want to raise attention to yourself, you can just raise your hand. And for this, you click the little button with the hand on it, and then we can see that you want to communicate with us and unmute you. And there'll be opportunity to ask some questions and interact with us in between the different presentations. Also, you can ask questions in the little question box. That's also in your webinar window, and I will either respond to them immediately in the question box, or I will introduce your questions after the presentations to the audience.
Okay, thank you, Lisa. Then before we now delve into the content of the webinar, what we would like to do with you is to quickly know actually what your background is. So we will start a little poll here, asking you about what kind of organization you represent. And I would like you all to fill this quickly out. I'll give you a few seconds for that. Okay, thank you very much. So what we can see is that there is actually quite a lot of people from other kinds of organizations. So I would be curious as to what kind of organizations we actually missed out on here. But we also have research institution and very few people actually from local administrations, consultancies, and public transport operators. Okay, well, then I would say we'll delve now into the project content. And what I would first of all do now is to introduce you to the ELIPTIC project. For those of you that have never heard about it, we are a Horizon 2020 research and innovation project. ELIPTIC stands for the electrification of public transport in cities. We are in total 33 partners from 8 different countries, and we have been showing our efforts in 20 different use cases, both being demonstrators but also feasibility studies. And the duration of the project is 3 years. It has already started in 2015 and will now come to an end in May 2018. There's also a final conference which we are, which the city of Bremen will host in the end of April, and we will also share the invitation to that and the registration link to that with you at the end of this presentation. All presentations that we will be giving in this webinar and the recording of the webinar itself as well will be made available on the website. So yeah, don't worry about that. Don't take too many notes. We will be sharing everything with you afterwards. The overall budget in the project was 6 million euros. In ELIPTIC, we've been looking at these 3 thematic technology pillars. Pillar A was e-buses, the safe integration into existing electric public transport infrastructure. We have been looking at both technologies. We've been looking at battery electric buses, but also we have been looking at extending current trolley bus lines with trolley hybrid buses. Then in Pillar B, the topic was energy efficient electric public transport systems. So we've been studying the possibilities of better storage, like through flywheels, but also making the public transport energy infrastructure more efficient by having reversible substations. And then in today's webinar, we will be focusing now here on the last thematic technology pillar, which is Pillar C, the multi-purpose use of electric public transport infrastructure. And in this topic, we've been looking at the possibilities of charging other electric vehicles like pedelecs, electric cars, taxis, utility trucks, and electric buses. Just to show you quickly where we are from and which cities have been involved in the projects. As I said before, in total it's 11 cities that have been involved. Today present are London and Barcelona, but we also had cities like Oberhausen and Leipzig, Szeged from Hungary, Lanciano from Italy, Warsaw from Poland, and Gdynia from Poland. In the project, we also had a few main associations, both national but also international ones like UITP. And we also had a learning and sharing program involved, which was the Twinning Cities and the user forum, consisting of various public transport operators and authorities. In the project, we've been looking at different bus charging technologies. We had opportunity charging, overnight charging, as well as charging en route. That would hold true for the trolleybus systems. And we also looked at different battery concepts. That would be low capacity battery concepts, but also large capacity ones, like in Bremen, where they only did overnight charging. One of the very important lessons in the project was that we learned that funding looks rather bad for electric buses. And in contrast, there's quite a lot of focus and funding streams available for electric cars. And that's why we came up with the Factor 100 campaign, which mainly tries to communicate to policymakers that if you really want to do something for European cities, if you really want to make them more sustainable, healthy, livable, etc., then what you should actually look at is the electrification of buses and give funding to that. Because if you compare the two, the passenger car and the bus, you see that passenger cars use less than an hour, whereas the buses use 12 to 16 hours. And because of that, you have a 500-liter gasoline or diesel consumption from a passenger car. And for the bus, that is up to 40,000 liters diesel per year. So if you look then at the corresponding CO2 emissions per year, then you see that the bus emissions are 100-fold compared to passenger cars. So because of that, we wanted to make sure and raise awareness on having more funding streams available for the electrification of public transport and especially buses. Okay, that's enough about the ELIPTIC project. What I would like to do now is to give you a quick introduction into our topic of today, the multi-purpose use of electric public transport infrastructure. And our idea here was that the concept here was that we wanted to reduce the costs and the energy consumption by optimizing electric public transport infrastructure and rolling stock. So we really wanted to strengthen the role of public transport, really making it backbone of our city's transportation systems, and then looking at the possibilities to have micro-mobility solutions and vehicle sharing solutions to cover first and last mile, ideally using the same infrastructure. And you can also see that here in this concept, you see that the metro, the tram network is being used as well for the charging of electric buses, but also for other electric vans, cars, and ideally also integrate renewable energies. This was the idea we had in the beginning of the project, and then we formulated a few guiding questions, some research questions for the next years that we've been looking at mainly, and these were mostly where to place multi-purpose charging infrastructure. So looking at where are ideal locations to actually put the infrastructure. Then looking at what different parties need to be involved. So are there new cooperations required? For instance, what actors do public transport operators have to talk to when thinking about solutions like these? Very important, what are the economic advantages to use existing electric public transport infrastructure, and is there actually a business case? And this has been one of the core research questions in the ELIPTIC project, to really look at whether there is a business cases for public transport operators to provide these services. Something that has become more and more important over the course of the project is the last question, the legal barriers, for which we also have a presentation now, because we have encountered quite a few legal and regulatory barriers that currently still prevent the multi-purpose use of public transport infrastructure. Okay, if there aren't any questions at this point, then I would hand over now to my colleague David Talbot from Transport for London. Just a second. David. Okay, you should have gotten the screen now, and I would also like to ask you to unmute yourself so that we can hear you.
Hello everyone, hopefully you can hear me now.
Yes, works perfect, thank you.
Okay, I'd like to take a short time to talk to you about Transport for London's role in the ELIPTIC project. In particular, how we've looked at how we can use our London Underground electrical infrastructure to support the charging of our own support fleet. That's the vehicles our engineers use to go about their business, typically ranging from the car-sized vans like Renault Kangoos up to the sort of Ford Transit size vehicles, and also how we can start to use the Underground's infrastructure to support the electrification of London's rather large bus fleet. To give you a bit of context of why we're doing this, London is a fast-growing city. At the current rate of growth, it's increasing in population by about 1 million people every decade, which obviously puts a huge stress on all the infrastructure of the city, the electrical infrastructure, the general social structures, and the transport infrastructure. A huge amount of transport goes on across the city, as you can imagine, and this is having a very detrimental effect on air quality. And air quality is one of the prime political concerns about the environment of London at the moment, and widely recognised by the public as a major issue that is facing them. The political will is there. It's thought that the air quality is contributing anything up to 10,000 deaths, early deaths a year in London. Obviously a major problem. At the same time as this, we've got a major uptake in electrical vehicles. If you know London, you'll probably recognise the small orange blob in the centre of this map as the congestion charging zone that's been operating for over a decade now, whereby anybody driving in that zone has to pay a daily charge. In October last year, that also became a low emission zone, the T-charge zone, where vehicles that don't meet at least Euro 4 standards also have to pay a daily charge to drive in that zone. This is all driving the uptake of electric vehicles, but of course electric vehicles need somewhere to charge. And London's electrical infrastructure is already struggling to cope with the demand from that fast population growth, both in terms of the quantity of electricity that's available, the generation capacity, and in terms of the distribution network. It's often very expensive and very time consuming to actually increase the level of electric supply to a premises you'd need to charge a fleet of electric vehicles. The buses provide us with a particular problem. Obviously a major contributor to the transport related emissions in the city, but we have a very complex and very large bus network. Over 9,000 buses, 675 routes, and about 500 million kilometres travelled, transporting 2 billion passengers every year. And one thing about London commuters is they're not interested particularly in what technology they've got, what their bus is like. They just want to be where they want to go at the time they want to be there. So one of the key points we've got to address in all this is making sure we can deliver the service that our customers require. So what could TfL do to ease this problem? Well, we already have, in effect, a major private electricity grid that spans the city. Deals with about a terawatt hour of power every year, and it's called the London Underground. You can see in this map roughly where all the transformer rooms and switch rooms that we can access the underground electricity network are. Sometimes it's deeply buried, Sometimes we could get power from it to charge electric vehicles, no problem. Other times there are huge constraints from the simple operations of the underground. It is a major electricity grid. It's thought to be about 4 times more reliable than the national electricity grids, but that is because of the operating rules and the high maintenance that's put into it to avoid putting passengers in danger and keeping them trapped in tunnels. For the 100 or so years that the underground has operated an electric grid before the ELIPTIC project, it has one purpose and one purpose alone, and that is to power tube stations. So there are quite a bit of work to be done in this project just to get the change in policies and operating rules to allow the charging of electric vehicles, which is why we went with a small scale demonstration to start with, looking to just prove that connecting EVs, one, didn't break the underground, and two, that the electrical vehicle charging equipment could cope with the, yes, high reliability supply from the underground, but also a very dirty power supply, thanks to all those tube trains accelerating and braking. So to demonstrate this, we had to select a demonstration site where we had easy access to the underground network. Digging up the street in London costs about £300 per linear metre, so obviously huge constraints there on what we could achieve within the scope of this project. We also had to consider how much power we'd be asking for. Is it the power to do several buses? Is it the power to do, say, half a dozen 7 kilowatt charge points? We settled on the latter for our demonstration. One, because it was easier to find a location we could do this. Two, because we could also be entirely within our control. These were vehicles of our own support fleet rather than buses, which London TfL manages the bus routes. It specifies the contracts, but all the buses are operated privately. The ELIPTIC project, in effect, was a proof of concept. That, as I say, we can use the underground's electricity infrastructure, connect it up to standard electrical vehicle charging infrastructure, and charge vehicles in the way they need to be charged. We chose a depot in West London called Lily Bridge Depot, which you can see in this map. And as you can see, we've got the underground lines running right next to the depot. We have TfL substation on site, and we also have a large number of our small fleet vehicles, the Renault Kangoo sized vehicles based at this depot, which we could directly swap out the diesel vehicles coming to the end of their life with electric vehicles to operate in the future. So our main priority in the ELIPTIC demonstration was to demonstrate we could safely connect these infrastructures to the grid with no effect on the reliability and the sustainability of the underground's operations. We installed 6 standard double-headed 7 kilowatt charge points. You can see 2 of them here. One of the other ones is just off to the left of the photo here, and we took a stepped approach to the testing of these, starting with just one vehicle trickle charging. Did that introduce any harmonics into the underground's power network? Did it cause any disruption to the power network? Once that was okay, we went up stage by stage to all 6 charging from essentially flat batteries, at which point, having demonstrated that that could be done without introducing harmonics, the underground's power engineers were happy that, yes, this is one, we can operate this as a regular facility now. So those 6 vehicles are in the London Underground fleet operating from these charge points, but also it proved the concept, meaning that, yes, this is something we can do with the underground's power grid and still deliver the service that we're committed to delivering. So going forward, what else can we do with this? Obviously, those buses are a huge contribution to the air quality issues in London, and we took a look at how we could electrify buses through both opportunity charging en route and overnight charging in the depot, which to some extent is the preferred option within London. As I say, hugely expensive to implement new on-street infrastructure, but slightly more realistically priced to put a large pipe of power into a garage, one of those 90-odd bus garages we've got around the city, be that a connection from the national grid or a connection from the London Underground. But would that sort of connection actually support delivering the level of service we want? We've done a case study on several of the routes in London, and this is just one of the typical ones. From Baker Street up by the north, by St Pancras Station, that sort of area, down to Putney Bridge, going across the city. As you can see, this is a 24-hour-a-day bus route. It operates well over 1 million kilometres a year, carrying over 5 million passengers a year, with a daily vehicle requirement of anywhere between about one bus every 7 minutes and one bus every 15 minutes in the hours of the night time. Individual buses operating anywhere between 45 kilometres and 200 kilometres a day, consuming anything up to 300 kilowatt hours of electricity a day based on current buses that are available in the market. 25 buses based in the garage at Putney which serves this route, and a key point here is at no time are all of those 25 buses in service, so we do have some flexibility there. 19 buses will be operating during the day, 3 buses operate both day and night, and 3 buses deliver the nighttime service of 1 bus every 15 minutes. So, could we actually power these buses by just overnight charging? Some of the buses will, yes, operate that level of charging service with their overnight. Other buses will be consuming far more electricity than the battery capacity on board. As you can see, 2 particular buses, over 90% of their capacity, even with opportunity charging brought in. This is assuming we could build opportunity charging at the far end of the route, where there's typically 13 minutes turnaround time, and using over half that time for pantograph charging. If we can successfully electrify this route, the savings of just this one of the 675 routes are significant. 844 tonnes of CO2 a year saved, well over 500,000 litres of diesel that we don't burn, and particularly important, 18 tonnes of NOx reduced, 32 kilos of particulates not emitted into the atmosphere. So, in conclusion, the London Underground can supply the power for both our fleet vehicles, easy to control, and buses cost effectively. Geographical factors are hugely important. Whether you choose the national grid, the London Underground grid, a lot of it is going to be simply down to the proximity and ease of access to the power infrastructure. Again, that £300 a linear metre for digging up the street soon puts up the cost of the project. While we've proved the point that 6 Renault Kangoos don't break the underground, we've still not got general acceptance that we can do whatever we want in terms of electric vehicle charging from the London Underground grid. So we're now in discussion with one of the bus operators to electrify a garage with about 200 buses based on depot-based overnight charging for those buses connected to the London Underground system. All those figures I showed you earlier were just traction power. Heating has a major impact on the electrical power requirements, but again, that is showing how we probably need the end of route opportunity charging as well as the depot-based charging. That route I talked about, yes, we could do a service with the heating in operation, but that would require end of route charging anywhere between once and twice a day for some of the buses doing the least mileage, up to almost every day for the buses that are doing the heaviest duty, almost every time it goes through the end of the route for the buses doing the most route services each day. Future rollout of this, as I say, we're looking at how we can implement this solution with the London bus fleet. It's never going to be the total solution to the electrification of the London bus fleet. That is simply too big for the Underground's power network to cope with distributing the amount of power required for that. But it will be a solution in certain circumstances where, for whatever reason, it isn't viable to connect into the national grid. Within the TfL estate, we're doing a lot of work now to bring in sustainable electricity generation, things like solar and tidal in the river services. How can we integrate those into the network and into electric vehicle charging? And also, Transport for London is just one part of the public sector in London. Other parts of the city's administration operate large vehicle fleets as well. How can our learning be we're looking at how our learning can be transferred to other organisations within the city administrations. Thank you for listening. I'd be happy to take any of your questions now.
Okay, thank you, David. Thank you very much for the presentation. I'm looking over to my colleague now. If we got any questions from the panel, from the participants.
No questions so far.
That doesn't seem to be the case. Okay, then David, I would have a question for you. Are you planning to connect more service vehicles now in the next few months to the London Underground, or will it remain? Will it stay with those 6 vehicles only?
It will certainly stay with those 6 vehicles for maybe the next 6 months or so. But going forward, we're looking at various research projects integrating this sort of technology with connecting renewable energy into the London Underground grid, smart energy management, all that kind of thing over the next 2 to 3 years.
Okay, sounds good. And what would be the impact on electricity supplies if you think about fully electrifying London's buses?
Okay, this is where the numbers start to get a little bit scary. London Underground is already one of the 5 or 6 biggest electricity consumers in the UK. As I said earlier, the Underground takes about a terawatt hour of electricity a year to run it. Just electrifying those 9,000 buses is going to take about the same amount of electricity again. To put that into context, that's a medium-sized coal-fired power station running at capacity 24 hours a day, 7 days a week. Hence why we're starting to look at these alternative generation strategies. It doesn't really do a great deal for the environment if you're just powering your electric vehicles with dirty electricity.
Right. In the meantime, we have a question from the audience now.
Yes, the question is there a plan existing at which points the buses can be charged, and also at which time? Because not all of the buses can be charged at the same time.
That will very much depend on the operations of individual bus depots. For example, we currently have electrified with a connection to the national grid our garage that's by Waterloo Station. That's about 52 buses. They have 45 charge points at that time. As I pointed out earlier, generally not all of the buses committed to a particular route will be out at any given time. So it comes down to how the operators manage that charging structures. Those 45 chargers are enough to keep all those Waterloo bus services running, and that's one of the major heavy commuter services that runs across the city from Waterloo Station to London Bridge Station.
Okay, thank you. There's another question.
The question is there a preference for AC or DC fast charging?
At the moment, we're focused on AC charging because, pure and simple, that is the simpler engineering problem in connecting with the London Underground grid. As you probably realise, it is an AC and DC network, but the technology is far more advanced, far more ready to connect to the AC grid while still being able to assure that level of service and not break the underground.
Okay, thank you. And another question.
The question is TfL looking into energy storage solutions?
Yes, that also features into some of our future research projects. We're looking at various things to smarten up how we use that underground electricity grid. And yes, energy storage and bidirectional charging of electric vehicles are going to feature very strongly in our research agenda over the next 2 to 3 years.
Is there any technology in particular that you're looking at when it comes to energy storage?
Storage, we're generally looking at the battery storage, the sort of container-sized batteries, be that either new or second life batteries. At the moment, we're really testing the technologies we can use, and everything is on the table.
Right. Yeah, okay. Thank you. Also, thank you for the good questions from the audience. If there is nothing else now, then I would hand over to Oscar is next.
Hello.
Just a second, I'll give you the presenter's rights. Yep, okay, we are able to see your screen. Then I would say you can start.
Okay, thank you very much, Henning. Well, for starters, I would like to say that we are not London Underground, and we are not London, so our problem is quite different from London. We, BSM, as a company, Barcelona Serveis Municipals, what we do is we manage different assets for the city council. In between those assets, there are certain assets related to mobility, which would be the parking lots. We've got about 50 off-street parking lots, and we also manage the on-street parking regulation, which means motorbikes, urban freight, and also private cars. And in that sense, we thought that participating on the ELIPTIC project would help us to learn how to improve the electric vehicle demand and also to try to gain some momentum in the city for these electric vehicles. So it's a broad project that understands mostly the sharing and the private use of the electric vehicles, not the public use, because TMB, which is Transports Metropolitans de Barcelona, is also on the ELIPTIC project, and they manage the bus company. So we are not going for the use of the public transport infrastructure for sharing and private uses. So having said that, Henning has talked about the project, so I won't step on that. But I would say, why are we on the project? Why is Barcelona on the project? We, as a city, think that it is important to be more sustainable and decrease the greenhouse gases and the noise pollution, and that's a part of our strategy as a city. So what we do is we try to improve the electric vehicle. We also try to increase the resilience as a city by optimizing the energy use of the railway operators, and just trying to have different sources of power so we can help the energy used to be much more efficient. And we want to be more efficient and more effective in the electric charging service for the citizens. So these are the three main reasons why we are on this project. And our approach of the project would be 3 steps. Our first steps would be to analyze the infrastructure, and then analyze the operation, and then analyze the strategy, how to deploy all of what we've learned from infrastructure and from operation. And this sounds just a bit, I would say, easy or obvious, but for us, it has not been that easy, because there are certain legal issues that always are a big barrier for this kind of projects. So when we started this project, and I'm talking about, well, we started this approach of using electric infrastructure from the public transport for different means, and I'm talking about maybe 10 years ago, we always stopped when there was the legal barrier. So on this project, what we've tried to do is try to take the opportunity that ELIPTIC give us, just to forget about this barrier and just try to get to the strategical point and understand if it's feasible or not, if it's interesting or not, and then we will talk about the legal barriers. So we started with a demand analysis, an infrastructure analysis, and an operational analysis, understanding the basic KPIs that we would analyze and that would make the project a success, and then analyze the cost-benefit opportunity. Then, with a legal analysis and a stakeholder analysis, define the strategy to follow and what to do with this network and how to grow on this network. So when we are talking about the demand, we're talking about first analyzing the requirements to connect to the railway grid, analyze all the parking areas in the city, and that means the basic systems and the ones that are more interesting for us, which would be the taxi parking areas. These are the taxi stops, and we are encouraging taxis not to just roam on the street, but to stay on their stops and to make people go to the stops to get the cab. The areas for loading and unloading goods, and that's urban freight, and we regulate those areas. The regulated surface areas, we have resident areas, which are typically green, and then the non-resident areas, which are typically blue, and then the underground parkings. And we have started with our own parkings, but we know that's a solution that could go for another parkings because they could be interested. When we finalize all the offer, then we have to exchange with the demand of those areas and understand the occupation. So that way we understand what is the main opportunity for us in terms of demand, and just trying to act on this demand, act on these users, to try and make them change to more efficient electric vehicles. Then what we do is try to distribute the forecast charging points needed into consideration, understanding how the demand will grow and what are the main trends in electric vehicle. So what we do is just an approximation. What we do is overlap the railway network and overlap with the offer areas, and then this way we do is we try to find the points that would be candidate to be resilient points, candidate to be elliptic points. So on that way, what we do is just try to set up a map which overlaps all of it in Barcelona for underground fast chargers, on street, fast charge, motorbike, freight vehicles, taxis. So currently about 42 of the 125 charging stations that are currently on street shall fall in the area of the influence of the railway lines. That doesn't necessarily mean that they are feasible, but it means that they are interesting points to study. So what we want to do is just to try to go and try to distribute the future points for recharging And what we've done is try to understand the uniformity in the urban areas and the density of the different parking areas to set up a network that on the future will hold the demand. And that's done into different stages and an approach of knowing exactly what would be the use of them. We also try to take into account the distance to the railway grid, because as David before said, one of the main investments would be the line of cable that you send between the railway and the charging point. So this is mainly the main driver of cost for this kind of installation. So taking into account the demand, we analyzed infrastructure, and what we've done is we've done through a holistic approach of the different networks. So this doesn't apply to the metro network or to the tram network, but it applies to all of them. And mainly what we've done is that typically the best way to connect is to connect directly to the transformer bars on AC 420. So this way, what we've done is we have the best cost solution, because we don't have to convert AC, DC, and then AC again, or DC, AC. And so that would be the best solution from what we find so far. About the infrastructure, we have to take into account different aspects of the infrastructure to make it grow. So what we have to take into account is different charger types, slow and fast charging points. And what we've seen is that the best infrastructure for our solution, for our demand, is that on street we go mainly with fast, and then off street go mainly with slow. This is here in the infrastructure growth, but later on the strategical point, what we've done is we've talked with the main stakeholders. So our main stakeholder, which would be the city council, agrees that the best strategy would be to have a high rotation on street and a lower rotation off street. Also, we have to understand the different management model and all the agreements that have to happen between the rail operator and BSM in terms of infrastructure. That means the maintenance of this infrastructure and also the monitoring systems for this infrastructure. And also, what we try to understand is what would be the demand forecast for the railway. And what we understand is that not all the points can be sourced all the time by a railway operator, because they have different needs. There are different two peak times, one in the morning, one in the afternoon. And during these peak times, it may be possible that we cannot have energy from them. So mainly what we've learned is that on street, we will have to get a different source, and maybe two different sources, one from the national company and one from the railway company, in order to exchange between these sources during the peak time, if it's necessary. And then on off street, what we've learned is that mainly we will be able to have energy from the railway during night. So that's quite good for us, because we understand that during night is when our cars have the lesser rotation, so we can have them charging slowly, and that would be a very positive way of using our railway network power. So we have taken into account different alternative scenarios for the operation, and that is something that we've came up with, which would be the use between public and private. The use means who's the final user. When we're talking about public, we're talking about public fleets. And counting on public fleets, we take all the administration fleets, just as policemen or a fire department or a taxi. So that would be public, whereas private is just a private user. So we understand that selling to public could be done by different arrangement between different public institutions that would make easier to sell the energy to them, because maybe you cannot sell, you will be able not to sell kilowatt hours, which is the main issue about selling energy, but you can sell a service. So on that way, we have two different scenarios. One, there is one cell only, and that is the railway company selling all the energy only to BSM as the parking manager. And then there are two different sales, one from them to us, and then one from us to the public user, which would be these policemen or these different institutions. But we understand that maybe with only one electricity sale, just selling them to us and us selling the service, that would work. I won't get too long on that because I understand that Dr. Harvick will go through all the legal details. But on the second scenario, on the private use, our idea is that the railway company sells directly to our customer. So the customer will have two different issues. One would be they are paying in minutes for the parking, and they are paying in kilowatts hour to the railway company for the energy. So we are not selling the energy, it's a railway company that will sell the energy through our appliances. So on that way, that would be the arrangement. On the fourth scenario, what we would do is we, as BSM, sell the energy to the final private user, and the railway company sells to us the energy. So just talking about feasibility, we understand that infrastructurally and operationally, all are viable. It's not very difficult to find feasibility on this because the different arrangements can be easily set, and also the difference between buying energy from the national company and buying energy from metro company is huge. So it is very big. But we understand that right now it is much easier if there is only one sale of the energy. So it would be that the railway company sells energy to us, and the railway company sells energy to the user, to the final user. So that would be the most feasible scenarios in a legal way. But as I said, I understand that Dr. Harwick will help us with these issues. So what we've done is then we've gone through a different stakeholder analysis, and then using our stakeholders network, we've gone through a SWOT analysis, which you'll be able to see, and which makes it easier to understand. Maybe the main issues is that we understand that the technology is available. We understand that the charging points that are supplied by the railway power grid are and have efficiency advantages and also financial advantages for us and for the user. So it's important, it's interesting that we can use it. Then also we understand that the higher utilization rate of the railway network is a key point for them to invest on better and more power for this railway network. In this case, TMB and also Renfe and also FGC have different plans to grow and to have more power on their networks. So that's an approach that will help them as well in order to have a better demand on public transport, and also a better demand for the electric vehicles that are using this network. And we understand also that this strength that there is a future extension of the municipal electric cycling, taxi and bus fleet. So we are growing. So it's very important for us, this strength. On the weaknesses, we understand that our actual network consists mainly on slow chargers, and they should be changed. The energy supply for changing points is a second priority for the railway network, because we know that they have different priorities, and planning and implementation effort is quite high. So comparing to connecting to the grid, and I should add that it is politically complicated, because there is always, when we are not TFL, we have different stakeholders with different interests, so it would be very complicated for us, as well as to find the subsidies for growing in the electric vehicle. So that's more or less what we have here in Barcelona as our internal analysis. The external analysis is more or less the same in everywhere, so I will just skip it. And then I will get to our feasibility analysis conclusions. First of all, our infrastructural design and installation report tells us that we have to place, or to try to place, stations within recharging points within 300 meters distance rail to the recharging point. Important is that is distance between rail, I mean the catenary, or the tunnel, and the recharging point, because we know that the main driver would be these 300 meters, the main driver of cost. Also, we recommend the AC 420 connections at the transformer bar. And what we think is that it is important that to plan a scalable network that involves the main stakeholders, and considering also impacts on social cost, and try to get to them through this analysis of being more resilient and being more green, and having all of our stakeholders aligned on that. About the operational model definition report, what we've seen is that during daytime, we can combine the maximum energy that we can take from public transport with different sources, such as the national source, and also try to find greener sources. And that the charging manager, which is the person that will sell, well, the institution that will sell the energy, can be the PTO, or it can be us, but we have to be sure about the legal issues. About our demand, we see that the key variables to locate the resilient and non-resilient points are the uniformity of supply, the density, and the occupation of the car parks. The nominal power, meaning if it's fast or if it's slow, will depend on the placement. What we've seen so far is that going on street may be faster, and then going off street would be slower charging. And what we've seen is that the demand on 2020 would be about 331 charging points, and we are working to get there on 2020. Okay, and about our legal report, I would say that the actual regulations have been taken into account, but from what we've seen, and that's more politics than other things, we are thinking that they are going to be much more open. So we think that there will be more opportunities in the near future. Right now, the most likely is that only having one seller, one charging manager in terms of the actual Spanish law would be the most feasible on a legal basis. But even that is quite uncertain for us. I must add that since December, BSM is a recharging manager, so maybe that's a step that we have taken, and it's important. So our strategy is that we want to ensure the legalization. We think that it's important that there are improvements on the regulatory framework. We want to help us with the ELIPTIC project to help public services motivate to use 100% electric fleet. Right now, BSM has a rate of 74%, and you have to take into account that we manage certain public services, such as the toll car service, which are not easily electrifiable. And what we're trying to say is we want to add value to the infrastructure by setting up a price for the charge, and this will happen in the near future. Right now, what we have is that recharging for electric vehicles is completely free. And what we want to do is to add different values for this recharging. We want to line up with the principal players in the electromobility area. What we've done so far is we are members of and founder members of the LEAF platform. This LEAF platform, which is led by Angel Lopez, who's really a name into the electromobility ecosystem. And what we are trying to do is just try to encourage the growth of electromobility. And then we also want to work for more sustainable network growth, which would be adding resilience and adding efficiency through the ideas that we've learned from the ELIPTIC project. And I think that would be it from my side. And please, I will welcome your questions.
Right. Thank you, Oscar. That was a very interesting presentation. I would have a question. I would like to know what is the main lesson that you have learned when you conducted the viability study? What was the most interesting outcome of that for you?
Well, one of the main issues is that from what we've seen so far, it is important that the public administration works on this network. We've got a lot of different stakeholders, and some of them are private, and some of them just know and want to make their living on this network. And we understand that is something that must happen. But right now, seeing the demand so far, we don't see that there are a lot of different feasible points in terms of demand. So we think that it is important that we, as a public administration, try to set up this grid, and on the near future, we just can give up the control of this grid to private users. That is one thing that is important for us, is that demand is not growing as fast as it should be in terms of understanding that the network can follow. So we have to start on our way.
Yeah. Okay. We have one question from the audience here.
Yes, the question is the energy really provided by a railway company? Usually there's another energy supplier where also the railway company gets the energy from.
That is completely true. That's quite evident, yeah. But the main idea for us is that what we have the standard network, which is the network that all of us take the energy from, and that would be lower tension, not high tension. So what the metro railway does is to have a different alternative energy network. So going to this energy grid, what we have is different advantages, which would be first opportunity of resilience. We are not going to the same network as everyone does. We are going to an alternative one. And we have really big issues with our main network, because during summer, when all the ACs are on, all the time it falls. So using this alternative network ensures that we are much more resilient. And also there is a second issue, which would be that going to the railway network, what we are doing is to help public transport in having a higher usage of their network. Overnight it's not used. During the day it can be used, and the usage can be improved. And this improvement will go to help also public transport in finding new ways of business to help to make it much more efficient. So we know there are alternatives, and we are already using them, and we will continue using them. But we think that going to the public transport to help power recharging points, it's much more efficient in city terms.
Okay, thank you. Do we have another question from the audience? No? Okay. I would have one last question, since we're really good in time, I would say. Also the upscaling question to you. What is your plan for the next months and year? What will happen to the ELIPTIC project?
Well, the thing is that what we've done so far is we've gone with the ELIPTIC project, and that goals since we started. We started with the main stakeholders, taking the city council and also the different railway companies. So what we understand is that right now we are just setting up what would be a single manager for the whole recharging network or for the public recharging network. Right now, there are two different networks. One is off-street, the other one is on-street. The on-street is controlled by the city council, and the off-street is mainly controlled by BSM, so by us. So what we are trying to do is try to agree on which way would be the more effective in cost terms and in efficient terms to have just one public manager for this network, and that public manager would be the one that would make it grow to the number of points, 331 points that we've seen so far, that it is necessary to go on demand. So we are just still negotiating, but it looks very good that in the very near future, maybe before Bremen, we can have this public manager. And the second thing is that from what we've understood, there is a very big opportunity for these resilient points, and we've started negotiations also with a railway company in order to have our concept proof and in a very close time frame. So maybe during next year we will have our first resilient point. That will be quite easy because from what we've worked so far and on our feasibility analysis, what we know is that this is a very interesting way to go. So we understand that that will be important. And last but not least, what we are doing so far is just try to work with different stakeholders, and mostly with taxi and urban freight, because we know that they are the ones that do much more kilometers per day on our city. Taxis can do about 280, 320 kilometers, and urban freight from 25 up to 75 kilometers per day on our city. So what we are trying to work with them is to encourage them just to go to electric vehicles and to have some recharging points that will be dedicated to them. So that way, when we start a new point, we will know that it is feasible because it follows the month. So we will try to set up arrangements and just try to set up a price that is convenient, but is not very convenient. So we are not encouraging more kilometers. What we are trying to do is try to encourage the same usage as they have now, but on a greener way.
Okay, thank you very much for these interesting answers, and also thank you for the cliffhanger for the Bremen conference. So if you want to learn more, then you should definitely come to Bremen Hall. If there's no other question from the audience, then I think we can move on to the next presentation and also the final presentation, which will be given by Hartwig, and I will give you the presenter's rights, and please don't forget to unmute yourself.
Okay, so do you hear me?
Yes.
Okay, very good, very good. Thank you. Yeah, thank you very much for
the presentation on in full screen.
Yeah, sorry, I forgot about that. Okay. It should be working now.
Yes, perfect. Thank you.
All right. So my name is Hartwig von Bredow, and as Henning already pointed out, I'm a lawyer from Berlin, and we have a little law firm here with with 9 lawyers, and we are specialized in energy law and also renewable energies and also decentralized energy supply and energy storage. And we have done a little legal study on legal and regulatory challenges in the use of multi-purpose electric infrastructure. And I will try to explain some of our findings to you today. Of course, our legal study was basically on German law. So some of the things I will explain here might not be the same in other European countries, but I think the same challenges, or I think we are going to meet the same challenges in every European country, basically. So let me give you a quick overview of what we are going to see today. I will start with a little introduction, and then I will try to open up the black box, and you will see in a minute what I mean by this. We will then take a look at the new market roles a public transport company might get into and their legal implications. We will then take a closer look at energy storage and regenerative braking, as these pose very severe legal problems that we don't really have a solution for until now. And we will conclude with the policy recommendations that we try to come up with. Okay, first let's start with a little introduction. When we are talking about multiple purposes electric infrastructure, what I mean by this is that the PT grid is used for different purposes, meaning that the most common one is, of course, a way-bound public transport, as for example with tramways, but also with the London Underground, for example. And what is new basically is e-mobility, meaning that the PT company uses battery-operated electric buses, maybe trolley buses as well. And the PT company or third parties, Oscar already pointed out that there are different solutions to this problem, but somebody will install public charging stations. And these charging stations have to be operated by someone. But what is most important is that the electricity that is consumed by these charging stations and that is used to charge electric vehicles comes from the public transport electricity network. What is also new, or maybe not so new, is energy storage, for example, battery storage and flywheel storage, and the regenerative braking, meaning that the electricity is recovered when the electric vehicles brake and is fed into the PT grid. And something we face in our legal study as a new idea, basically, and I think you already talked about this before, Henning, is using reversible substations in order to have some interaction between the PT grid and the public electricity grid, meaning that the electricity that is regenerated by recuperation might be fed into the public electricity grid and therefore become more efficient. The use of this energy is more efficient then. So from a legal point of view, at least, the use of multipurpose electric infrastructure means to connect the energy sector and the public transport sector. And these two didn't really have all that much to do with each other before. But once we use the PT grid in order to charge electric vehicles, maybe the buses operated by the public transport operator, but also private vehicles, it becomes clear that we're not only talking about the public transport sector anymore, but also about just normal energy distribution and all the legal issues that we have to deal with when distributing energy and selling energy to third parties. And our main finding is that it seems quite unclear, and I'm very happy to hear, no, I'm not happy actually to hear that Oscar thinks the same for Barcelona. But to me, it seems unclear whether the current energy law is really suitable to properly rule out the interface between these two sectors. We've encountered a high number of legal uncertainties and risks, very complex and sometimes even excessive requirements. For example, reporting requirements, the measurement of different electricity usages, and also energy regulation that comes into play here. And we have also encountered a very specific problem, meaning that there is a risk, at least under German law, that you might be exposed to multiple taxation when regenerating energy or using energy storage facilities. And all of these may really hamper the further deployment of charging facilities and of multi-purpose use of electric infrastructure. So I will now come to the black box, and I just used this in order to explain to you why everything is so complicated, at least from a legal point of view. So right now, the current practice, as far as I know, is that the PT grid, the PT network, is actually looked at as a black box. So the assumption is that the PT operator is a final consumer of electricity. There's a public grid, and then there's the PT grid, and the electricity that goes into the PT grid is consumed, for example, by underground or trams. And we don't really think all that much about what really happens within the black box. But however, if we take a little torch and light up the black box, what we can see here is that there are trams that consume energy but also regenerate energy. There might be storage facilities, and there might be electric buses. So there's a high number of different consumption processes and generation processes, and from a legal point of view, you really have to differentiate between all these in order to understand what kind of taxation does apply, what kind of reporting requirements, what kind of contracts do you need. And it becomes even more obvious that there's no black box really, but that you have to take a closer look at everything when you open the PT grid to other consumers. The PT grid here is everything that's within the blue square. And once you have private vehicles or electric buses that take energy from this PT grid, it becomes clear that there are third parties involved and that you need supply contracts and everything else. And also, we presented here with these little red arrows. The reversible substations may lead to a situation where the PT grid operator actually feeds in electricity into the public grid. And of course, you can't just feed in electricity into the public grid. You need some balancing, you need a contract, you need maybe exchange authorization and stuff like that. So you have to think about this as well. Okay, so the legal questions and challenges we are facing when we open up the black box and when we think about enhancing and opening the grid system to electric vehicles are the following. First of all, we have to ask ourselves whether there is a suitable legal framework for energy storage, as we're using storage facilities, for the recovery and also the use of break energy, for charging electric buses and other electric vehicles with electricity taken from the PT grid, for the selling of electricity to third parties, and for, as I pointed out already, for feeding electricity into the public electricity grid. So the main challenges that we are facing here are how can the PT operator distinct the different processes of energy consumption and energy generation? What kind of metering and measurement does he need for this? Also, how can he distinguish between discounted electricity consumption and non-discounted energy consumption? So I'm going to talk about that in a minute. And how can we avoid multiple taxation levies? Also, the PT operators have to get used to taking over new market roles. One might be, maybe it always depends on how you really set up the contracts, but one might be that it becomes an energy utility, vendor of electricity, and the other might be that maybe the PT grid all of a sudden is no longer like more or less a private grid only for the company itself, but it might become a general supply network that may underlie regulation and supervision, for example, in Germany by the Federal Network Agency. And of course, you have to think about the interactions between PT grid and public electricity grid. Okay, now let's take a look at the new market roles and their legal implications. One new market role, of course, is that once you open up your grid for everybody, you might become an operator of a public distribution network. While the current legal status of PT grid seems unclear, in Germany, at least, we can say it might be a customer system for the company's own supply, and these customer systems do not underlie legal regulation. It becomes clear that you might at least have a public distribution network in a legal view, and energy regulation applies once you open it up. And if that's the case, then you have certain obligations towards other stakeholders. For example, you have to grant grid access, you have to be transparent, you have to avoid any discrimination, you have to have network charges, and you have to think about whether you are allowed to have network charges, or whether you're allowed to have your public, your PT grid in order to earn money with it, because it might be funded and you might get subsidies for having this PT grid and your public transport system in total. And you also have some reporting obligations and so on. So you have to really get used to this new market role in this case. And another new market role you might be entering is the one of an electricity supplier. And as an electricity supplier, there's many things you have to think about, actually. For example, in Germany, it is the electricity supplier who has to pay the EEG levy. EEG levy, for non-Germans here, means the funding for renewable energies that everybody has to pay for, and that it's not paid. You know, the funding is not paid by taxes, but by the EEG levy. And also, you have to register at the network operator. You have to pay taxes, electricity taxes, or at least register at the main customs office. And there's further regulations that apply to suppliers concerning the electricity labeling, accounting, contracts, and everything else. For example, if you sell electricity, you always have to label it. You have to tell the one who bought it where the electricity comes from, and that's not that easy sometimes. Okay, and if you feed electricity into the public electricity network, as I already said, you have to balance it. You have to think about whether you can provide grid services, for example, with energy storage facilities. And you need, of course, some kind of power purchase agreement or exchange authorization, or you have to have a contract with an electricity vendor who takes care of these things. Now I will come to the very special problems of energy storage and regenerative braking. And I will try to explain to you why we consider this a challenge. Of course, first of all, it's a good thing from a technical point of view, right? Because brake energy recovery means that quite a percentage of the electricity that has been consumed by trams or railways can be recuperated and can be converted into electricity again. And this electricity that we have recovered might then be used within the same tram, for example, for heating purposes, or it gets fed into the public transport grid, and then in an ideal case, it is consumed by another tram that is just accelerating quite close to the one to the tram that is braking. The legal questions that arise from this, however, have not yet been looked into very much, but we actually think that once public transport companies are starting to open up their electricity grid for electric cars, we do have to think about how we deal with brake energy recovery. So one legal question might be, do trams classify as electricity generating units, just like any other electricity generating unit that you encounter, for example, power plants? And if so, and I suppose under German law at least, there is no doubt about this. If so, what legal stipulations apply to the electricity generated by recuperation? Do we have a case of self-supply? Do we have an energy delivery? Who pays for the EEG levy? Is there a risk of multiple taxation? I will explain that in a second. And another legal question that we might ask here is whether trams can be considered kinetic storage facilities. And this might sound a little bit funny, but as in Germany, any kilowatt hour that is consumed somewhere is, well, you have to pay the EEG levy and maybe, for example, electricity tax for any kilowatt hour that is consumed somewhere, no matter where this electricity has been produced before, and whether you take it out of the public electricity grid or whether you you produce it yourself. And if you think about this, then if you have a storage facility, for example, there's a legal exemption, and this exemption is very important. The exemption says, okay, if you prove that you've already paid all taxes and levies for the electricity that got into your storage facility, then you don't have to pay the electricity, or then you don't have to pay taxes and levies for the electricity you take out of it, or the other way around. So you only pay once. And in our legal study, we actually have had to think about whether or not a tram can be considered a storage facility as well, because it takes in electricity and it kinetically stores it in a way, and then it sets the electricity free again once it starts a braking procedure. So there's a special section in the German law on renewable energies in the EEG, section 61K, and this one is very, very complicated, and you need to have a measurement concept that is seemingly, it's not possible to really employ this, but still we have to think about how we can deal with these questions. This doesn't work anymore. This is weird. I'm sorry. Oh. Okay, now we can go to the next slide. Sorry about that. Just a quick digression in order to explain to you and make it a little bit easier to understand what I'm talking about. The EEG levy for the consumption of energy has come up to 6.792 cents per kilowatt hour in Germany in 2018. So that's a very important economic factor if you have to pay for it or not. And the general principle is, as I already said, that you always have to pay this for each kilowatt hour of electricity consumed, no matter what kind of energy consumption you're facing. So even if you consume energy that you have produced yourself and that is not taken from the electricity grid, you still have to pay EEG levy as a general rule. Of course, there are some exemptions and limitations, for example, in case of self-supply. And there is a very important limitation of EEG levy for railways in Germany. And basically, it only applies to electricity that was consumed directly by the railway for the railway transport operation. And it limits the EEG levy that the public transport company has to pay to 20% of the normal value. And as I already said, there's from these facts, two main challenges result. One is, how can you avoid multiple exposure to EEG levy? And the second one is, how can you distinguish discounted from non-discounted energy consumption? As I've said, a public transport company only pays 20% of the normal EEG levy for the electricity consumed for the operation of railway transports. However, if some of this electricity that is taken into the public transport grid then is used for electric buses, for example, this doesn't apply. And when it's sold to third parties, it doesn't apply. And when it's being fed back into the electricity grid, it doesn't apply either. So you really have to have a measurement concept that allows you to really distinguish between these different non-discounted and discounted energy consumption processes. The problem of multiple taxation, as I called it here, in Germany we would say Mehrfachbelastung for those who speak German here, really shows with this example here. Where in this example we have the electricity grid to the left, and we take in, let's say, 2,000 kilowatt hours of electricity into the public transport grid. But if we look at all the different final consumption processes, there's like 3 trams right here, and then at the end there's some escalators and train stations and stuff like that. And if we take this together, we see that it adds up to 3,500 kilowatt hours. And of course, we don't want to pay EEG levy for 3,500 kilowatt hours, but only for 2,000 kilowatt hours. But under the current legal system, it's not that easy. As I said before, we would need to apply section 61K from the EEG, and we would need to measure any electricity that is regenerated by the trams and that is fed into the PT grid in order to do so. And that's basically very tough and maybe not possible at all. Okay, so this was a special problem we encountered when dealing with these aspects. You could also think of further problems. For example, if you take a closer look at a battery in an e-bus itself, this also is a power generating unit as you store energy and then you take energy out of it. And you might also think about who has to pay for the EEG levy taken from the electric bus battery and used in the motor of the electric bus. But I don't want to go into details here. Finally, let's come to the policy recommendations. Well, it's quite clear what we need. We need a better legal framework. And I only touched on some of the problems that we encountered. There's many more. But as Oscar already said, and the same holds true for Germany, of course, there is some willingness and some openness of the government in order to make things better. But it's our task to actually inform the government, to tell them where the problems really are in order to make it possible that there's some development and that things get easier and better. So we need a clear framework that regulates the role of public transport operators that are now starting to work on the intersection of mobility and energy, meaning that we need clear requirements and clarity about what requirements to fulfill. Also, we have to ensure, or the government has to ensure, that the legal framework allows for PT operators to provide multi-purpose use of their electric infrastructure without facing the risk to lose public subsidies that they got for the grid system and that they also get for the energy that they consume within the grid system. As I said, in Germany, for example, the EEG levy, but also electricity taxes are reduced for railway systems. And the new e-mobility related technologies and applications have to be covered by energy law, and we need better regulations on energy storage, on recuperation, and what is very important is that we need these and without excessive measurement requirements, which nobody really can fulfill. And overall, we need to reduce the complexity of legal requirements. So if we put it this way, on the one hand, the legal framework has to represent the specific role of e-mobility within the energy system. And on the other hand, government has to reduce the legal uncertainties and the complexity of legal stipulations. And of course, this is hard to achieve, both goals at the same time, but I think it's very necessary because right now there really are some obstacles. Okay, I come to an end here. I hope you understood what I was trying to explain, and I'm very happy to hear to answer to your questions. Thank you very much.
Okay, thank you very much. That was very interesting. Also for us, it was the first time that we heard about the results from the study. So equally exciting for us as the ELIPTIC coordinators. I'm sure there are some questions from the audience.
One question is, or rather, yeah, quite a long question. A private household nowadays has a contract with its energy supplier. Do you think in the future there could be some technologies who sum up all consumptions, household, car, bike, etc., and send only one invoice? Or is it more feasible to charge only on demand, which means a lot of bills?
Okay, that is an interesting question, and a question that is very hard to answer. I assume that, I mean, if you charge your electric vehicle at your private household, it's quite clear. You just pay the normal electric bill, the normal bill that you get from your electricity supplier. But if you go somewhere else, if you drive your car to another place, and you then want to have the same vendor of electricity that you have at your private household, right? You want to buy the electricity from the same person. Under German law right now, it's not possible, I think, because we have a stipulation, a very new one actually, it came into force only last year, saying that the the final consumption, well, the electricity consumed within the charging station is considered the final consumption of electricity, meaning that you have an energy supply contract between, well, some electricity trader and the operator of the charging station, but you don't have the normal rights that you normally have in Germany, that you can always choose your electricity seller when you charge up your electric vehicle, right? Of course, if you live in a house, you can choose the utility company that for your energy supply. But if you drive up your car somewhere else and charge it at a public charging station, and then it's the operator of the public charging station who's considered the final consumer of electricity. And this legal stipulation actually was meant, or was, well, the government had the best intentions, of course. It wanted to make things easier, but at the same time, it might cut into your rights as the operator of the electric car.
Is there another question from the audience?
Not a question, but rather a remark.
Okay.
One participant says that it's disappointing that legal boundaries are hindering existing technology and energy storage to be deployed.
I would say that is exactly the lesson we have learned in the project, yes. It is very disappointing. Hartwig, taking on this comment also that we just received, what would you say, because it sounded like a quite frustrating experience. What would you say now? What can public transport operators do at this point?
Well, I think it is important to be aware of all these problems. And if you are aware of these, you can try to go about and solve them. And solving these problems means that you interact with all the public authorities that are most important here. For example, in Germany, that would be the main custom offices. It would be the General Network Agency, the Federal Network Agency, sorry. And also what we are trying to do is to address these problems to the government, to the ministry in charge of these, and try to have better legislation. Because it is clear that nobody really wants to pose barriers to e-mobility. And so I think the government and everybody else will work on solutions for these problems. But of course, you have to know about the legal risks, and you have to find solutions to it, because otherwise you might end up having problems. For example, all of a sudden you're a public distribution grid system and you're not ready for this, right? You're not ready at all for all the requirements that come with this. So I think you shouldn't be frustrated. You should just know that things aren't that easy, and that we still have to work on some of these problems.
Okay, thank you very much. Very interesting. Lisa, do we have any other question from the audience? No, because we're also a little bit over time. So I would then wrap this session up, and I have a few last remarks from my side. Let me just quickly take over the screen again. Okay, just a second. Okay, yeah, I just quickly wanted to wrap up this session and say what the preliminary results from our elliptic experience has been in this, working on this field now for 3 years, and working on this research questions from the past 3 years. So we encountered quite a few existing barriers in the field of multipurpose charging. But as Hartwig said, we shouldn't understand this as a frustrating experience, but rather see that as a possibility to take action now and do lobbying and be ready for these kind of new services that public transport operators can provide. So first of all, we can say that it is technically possible to use tram, metro, or trolleybus energy infrastructure to charge other e-vehicles. So from a technical point of view, we have proven that this is doable. But then it is also very important to say that at this point, with the current uncertainties in the energy law, the internal use of energy is way less complicated, as we've seen in London, where electric buses are being charged and Transport for London service vehicles are being charged from the London Underground. That is way easier to realize than it is to resell the energy to third parties. And our prime example in the ELIPTIC project has been the city of Oberhausen that tried to do this. But unfortunately, there are no DC metering systems available, which means that in the end, the gauging office did not give the permission to operate the 3 fast chargers that Oberhausen has, which means that Oberhausen now has to sell the energy as a voucher to their customers. This is also something that Oscar was talking about, that currently you are not allowed to sell the energy per kilowatt hour or per minute. So we need to have better regulations for that. As I said before, and as we very well heard from the presentation from Hartwig, is that there are currently many uncertainties due to the shortcomings of the current energy law. So some things are simply not covered. Whatever happens in the black box, as he coined it, is not foreseen in the current energy law. And we don't know yet how public transport operators can deal with questions that are related to their taxation, to administrative requirements, if they want to also become energy providers, and also questions that are related to the measuring and distinction processes, for instance, related to non-discounted and discounted energy. One very relevant question in the project has been whether there is actually a business case for this these kinds of solutions. And we can only say that this highly depends on various factors, as always. It highly depends on the time of the charging, on the energy capacities of the grid. So you really need to analyze each substation individually to see what the free capacities are at each substation. And as, how did Oscar say it? In Barcelona, for instance, they recommended that the maximum distance to a substation should be 300 meters. But I think this also highly depends on each city. Also, whether you have to do cable work underground or above ground. So distance to the substations also depends on these local factors. Something very important that Barcelona has done is a needs assessment and demand estimation. So really looking at what suitable locations you have in the city, really planning this in a GIS analysis, and also looking, of course, at what and where the demand for electric charging points is, of course, because you don't want to end up with providing charging infrastructure that's not used in the end. So Barcelona has made the estimation that, what was it, that until 2020, you need 350 charging points. So this is just to keep in line with the policy goals and providing the charging infrastructure that you think will be necessary at a certain point. Consulting stakeholders in that process is a very important process, and I think this is also something that we can all really learn from the Barcelona case. Last but not least, there are quite a few technical constraints currently, especially whenever I talked to David from London, he said that the engineers are really concerned about voltage stability. This will, of course, never change because providing metro and tram services should still be the primary thing to do for a public transport operator. But as he said, a step-by-step approach might help to overcome this anxiety. As I said before, in Oberhausen, we've encountered the situation that there is a lack of charging systems and chargers on the market, as well as a lack of standardized DC metering systems that makes it impossible right now to have a clear billing and charging process with DC energy. Okay, and finally, if there are no other questions from the audience anymore, which no. I suppose there aren't, then I would like to thank all of you for your attention. It has been a very exciting webinar for us as well. We hope that it was the same for you, of course. If you want to learn more about the ELIPTIC project, please visit our website or the social media channels that we're on. And of course, you are all invited to join us at the Elliptic Final Conference, which will take place in the end of April in Bremen. There are still registration is still available and possible, so please do that if you want. The conference is provided for free. In terms of the webinar, we will send out a follow-up survey tomorrow to learn about your experiences and to see whether you liked it or not. We will, of course, also provide a link to the recording of the webinar, and we will make all presentations available, and also send you a link to the Elliptic training platform where you can find the other 2 webinars. So yeah, thank you again, everyone, for participating today. I would also like to extend my thank you to the panelists. I think we've seen quite a few interesting presentations today, and yeah, without further ado, I would just I would say hopefully see you all in Bremen again. Bye bye.